Okay, I'm recording. I'm doing this practice problems paper from something, and I'm gonna do the show how to solve each of the questions one by one for this session. And please ask any questions if you want to, and yeah, that's it. How many people are actually gonna stay in this session? Well, you decided to stay, Yusra?
Yeah, I need math.
Okay, fine. So first question. Megan designs a decorative glass vase for a new fine arts center. Wait 1 second. Actually, I think I can. Okay. I'm gonna copy over the question from here. I'm gonna put it into whiteboard. Okay. So Megan designs a decorative glass vase for a new fine arts center. What the hell? Okay. The glass vase is made up of small triangular panes. The first 3 levels of the glass vase are illustrated in the following diagram. The first level at the bottom of the glass vase has 5 triangular panes. The second level has 7 triangular panes, and the third level is 9 triangular panes. Each additional level has 2 more triangular planes at the level below it. Find the number of triangular planes at the 12th level. So start with our information given. Our sequence on the first level, which is at U1, is going to be equal to 5. So the first level. So U1 is going to dictate the first level. UN is going to dictate the nth level. Then U2 is equal to 7. U3 is equal to 9. I'll just write out the sequence. It's going to be 5, 7, 9, and so on. Each one has 2 more triangular planes in the level below it. So find the number of triangular planes in the 12th level. I've written out the first 3 levels. It isn't too difficult to write out the first 12 levels for this situation. I could do 11, 13, 15, 17, 19. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 27 panes in the 12th level. You can write it out, and I'm pretty sure it'll give you the 3 marks for it. Or if you feel like doing so, you can recall the U-nth term is equal to the U1 term plus the common difference times n minus 1, which is shown in our formula booklet, which is right over here. It's the formula right over here, in SL 1.2, nth term of the arithmetic sequence, UN is equal to U1 plus n minus 1 times D. So if you feel comfortable, you can use this formula, and then you would check U12 is equal to U1 plus 11D, because it's 12 minus 1, 11D. U1 and D, you know, U12, so U12 is equal to U1 is equal to 5, that's the first term, written over here. And D is the common difference, which is 2. So that's plus 11 times 2, and you get the same answer, which is 27. Those are 2 ways in order to solve this problem. So moving on to the next part. Go back here. Show that the total number of triangular planes Sn in the first n levels is given by Sn is equal to 10. So this is asking us for the sum of an arithmetic series. Some arithmetic series. Let's recall the information given to us. U1 is equal to 5, D is equal to 2. These are the pieces of information which will help you solve for everything. Now, go back to your data booklet. Look at the sum of n terms of an arithmetic sequence. So you have, we can choose this one. So I'm going to use this formula right over here. You can use either one of the formulas, but eventually you'll need to use, you'll get back to this one, and you'll see why. So if you use this formula for the sum, this is how you would do it. You would know that Sn is equal to n over 2 times 2u1 plus n minus 1 times d. I can rewrite that as, I can rewrite this as n over 2, 2 times 5, because it's given by u1 over here. We already have it written down, times n minus 1 times d, which is 2, written over here, which then I can expand this out and write it out. So I have 2 times 5 over here. This is equal to 10. So 10 times n over 2 is going to give me 5n. I'm multiplying these two terms. Then I'll multiply the n over 2 times this, and I'm going to get plus n times n minus 1. And that's it, because I have a, because the 2 over here and the 2 over here cancel out. Because I have 2 times n minus 1 here, times n over 2. The 2's will cancel out. I'll have n times n minus 1. Then I can rewrite, and then I can expand n times n minus 1, and I will get n squared minus n. And I can rewrite this as n squared plus 4n. And that's how I use that formula. Note, it's the same thing. It would be the same thing if I decided to use the other formula. So you know how there's two formulas for the arithmetic sequence? I would get a similar result if I use the other formula. They both work. Where's the chat? What happened? I'm going through how to solve it on the whiteboard. Yeah. And I'm sharing my screen so you can see that. Okay. That was the question I'm asking. It was a question in the middle. So here.
Formula booklet.
What?
We can only see the formula booklet.
Wait. Oh my God. Okay, I realized what happened. Okay, I'm gonna do this 1 second. So I had a whiteboard. That's the problem. And you didn't see the whiteboard. Here's the whiteboard, by the way, guys. Can you see my whiteboard now?
Yes.
Yes. So I made an error. So I'll start off from what I did before. For the triangular planes, I started off with u1 is equal to 5, and then listed out the sequence up until 27. That's the first method I could solve this. The second method, I used the algebra over here. un is equal to u1 plus d times n minus 1, which is in the formula booklet, and I continued using that. And then below, for the second part, this is the working I have over here for this. Again, this is now, it's finally recording it, so you'll be able to see all of these things in the recording. But this is, yeah?
4. Where did you get 4?
4?
Yeah.
This 4n?
Yes. No,
Yeah.
like, and then 4 minus 1.
Wait, which 4?
Oh, that's n. Okay, never mind.
Oh, okay. Yeah, that's n over 2. So this is the algebra I use for this. But that's using specifically this formula over here. The Sn is equal to n over 2, and that's the expanded version. But note how there's another formula over here, and you can use that one as well, and it's going to give you the same result. I'll show you that just now. So if I use this equation, it's going to give n over 2, and I'm going to get u1 plus un. I'm going to rewrite. So we already know that un over here is u1 plus d times n minus 1. So I'm going to rewrite that as u1 plus d times n minus 1, just to rewrite it, right? And then I can simplify because there's two u1s over here. I can make it n over 2 is equal to 2u1 plus n minus 1 times d. And note, that's the exact same formula as the one over here. So ultimately, it doesn't matter which one you use, but you'll have to substitute things in, and eventually you'll end up with the same result. This is the same thing as this one. I was able to move this one and make it into this one, right? So I hope that makes sense. So this, actually the first formula over here comes from this second formula. So yeah, that's it's from an interesting little result in the derivation. But yeah. So that's how you solve this question. You show that Sn is n squared plus 4n. You could go back to here and then follow these steps down this way in order to figure out what n squared plus 4n is equal to. I'm sorry I wasn't sharing my screen properly before. It was like messed up. Okay. The next thing is the next one. Okay. That one here. Hence, find the total number of panes in a glass vase with 18 levels. total number of panes in glass will be 18 levels. What that means is the sum of panes up until n is equal to 18. So what you want is S18, right? The S18. Now you've shown that Sn is equal to n squared plus 4n. So S18 is equal to 18 squared plus 4 times 18, which then you can evaluate because this is paper 2. You can use a calculator to evaluate that. I'll give you 1 minute to do that. That's 396. That's the total number of panes. And the next part is 1D. So Megan has a 1,000 triangular planes to build a decorative glass vase and does not want to have any incomplete levels. Find the maximum number of complete levels that Megan can build. Now what you do is now that you have an expression for the number of now you have an expression for the sum. Sn is going to give you the total number of panes, and she has 1,000 panes. So you set Sn equal to 1,000. So you get Sn is equal to 1,000. I need to find a way to also show you my calculator. I think I have a calculator app here. I don't know. I forgot if I had one. It's okay. I'll do that. I'll figure that out later. Sn is equal to 1,000. Then I know Sn is equal to n squared plus 4n. So I get n squared plus 4n is equal to 1,000. Then I get n squared plus 4n minus 1,000 is equal to 0. So this is giving me a quadratic expression. And if I'm correct, I don't think this is factorizable. 1,050, 200, 5, 50, 40. Nope, it's not factorizable. So what I'm going to do is I'm going to use my calculator to solve for this. So what I'm going to do is I'm going to graph n squared plus 4n minus 1,000, and then I'm going to check when that function is equal to 0. So I'm going to show this on Desmos right now, but you can do this on your calculator as well. So on Desmos, I'm going to show n squared plus 4n minus 1,000. This is the way that you're meant to be solving. I'm not going to use n over here because Desmos doesn't accept non-n values. You only accept x values, and it's the same for your calculator. I'm going to zoom out. And this is what the graph looks like. You'll have to zoom out on your TI Inspire. And then you will have to use the Analyze button in order to check for zeros. And then drag the Analyze button over the positive value over here, the positive 0 you can see. I can click on it right now and see that that value is 29.686. So I go back and I see that n is equal to 29.686 with 1,000 panes. So if I have 1,000 panes, I can get up to 29 levels and then 0.686 more levels. But because it said that they want complete planes specifically, that means that I am able to complete 29 panes, and then a little bit more after that. But I only want to look at the complete planes. So that's why I only look at 29. So I know that my n is equal to 29 for if I have 1,000 panes being used. And that's how I did that part of the question. Again, to solve for this function, you plug this into your calculator, and you need to try and solve for, you can solve for the 0 using here. Alternatively, if this is a paper 1 question, which I doubt it would be, if it was, you would need to use the quadratic formula. So if instead of factorizing, so if you have n squared plus 4n minus 1,000, you know that the a is equal to 1, the b is equal to 4, the c is equal to negative 1,000. And then you can use the quadratic formula, which is x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Again, that's in your formula booklet, which is going to be equal to negative 4 plus or minus square root of 16 minus 4 times ac. So that's minus that's going to be plus 4,000 over 2a. which is just 2 because a is equal to 1. And then you can go ahead and try and simplify this all the way, but that's only for paper 1, not for paper 2, because it gets much longer. So if you notice, the marks on this question right over here is 3 marks. If it was a paper 1 question, I can guarantee it'll be significantly more than 3 marks, like at least 8 to 9 marks if you're going to be having to do all of this. So then it obviously takes more time and you'll have to take more effort to try and get to the value of 29.686. But otherwise, this is going to be a paper 2 question and not a paper 1 question. So next part over here. So oh, sorry. Here, so this is the last part of the question. No, that's the wrong thing. Wait. Okay, so now the final part of the question, each triangular plane has an area of 1.84 meters squared. Find the total area of the decorative glass face if the maximum number of complete levels were built. So that means this, referring back to the previous question, n equals to 29 is the maximum number of panes that could be built. And express your area to this. So they want to try to find out what the total area is if the maximum number of complete levels were built. So if 29 levels were built. Now we know that if 29 levels were built, we need to now again find what would be the number of triangular panes. You can't just use 1,000 panes because that's 29 levels plus 0.686 levels. So you need to figure out exactly what 29 levels is. So again, Sn is equal to 29 squared plus 4 times 29. And then you can solve for that. Give me a minute, I'll solve for that right now. For future sessions, I think I'll try and find a calculator application on my laptop so I can also show what my calculator looks like. That's 957. So you have 957 panes. That's less than 1,000 panes. So that's a good sign. That means that 957 looks like the max that you could possibly have under 1,000 panes. So find the total area. So you know each one has an area of 1.84 meters squared. So you do 957 times 1.84 meters squared to get. So I'm going to do that on my calculator. I'll get 1,760.88 meters squared. It says express your answer to the nearest meter squared. So you need to make sure that it's 1761 meters squared. You round upwards. And that's your final answer for that part of the question. Yeah. Okay, another sequence series question. So I'm gonna. Again, if you have any questions, turn your mic on and inform me of any such question. Oh no, this is the previous one. This always does this. 1 second. Everyone good with the first question? There's no questions needed? Okay. The first terms of an infinite geometric sequence are 2, 6, 18, 54. The first terms of a second infinite geometric sequence is 2, -6, 18, -54. The terms of a third sequence, Wn, are defined as Wn is equal to Un plus Vn. Now think about what this is saying. This means that Wn means the nth term of W. So the first term of W is going to be the sum of the first term of Un and the first term of V. So the first term of W is going to be the first term and the first terms of U and V added together, and so on. For each of the for every single term. So when it says write down the first three non-zero terms of Wn, what they're referring to is, so first let's just try writing down the terms of Wn, and then we'll look at what this question means as well. So if you look at, so I always like to rewrite the question, usually like rewrite what the information is, what the information given is, so to make sure that I have a better understanding, and it helps me think for a little bit about it. So I tend to do this, and I just tend to write out some stuff, so easy to work with. And now for Wn, I'm going to start writing down the terms. So Wn, so the first term of W is going to be the sum of the first two terms of U and V, the first terms of U and V. So 2 plus 2, that's 4. The next term is going to be the sum of U and V of the second terms. So 6 and plus negative 6 is going to give me 0. Then 18 plus 18 is going to be 36. Then 54 minus 54 is going to give me 0. And then if I keep going, I can notice that there's a pattern over here. Now for the next term of Wn, I need to sum up these two terms, but that's not been given to me. So now I need to try and figure out what exactly is the pattern happening in these two sequences. So let's look at this. The UN starts off as 2, so we know that U1 is equal to 2. And then we see that it becomes 6, then 18, then 54. So if you notice, the R value, the constant ratio for U, is equal to 3. You keep multiplying by 3 each time. So if you multiply 54 by 3, you would get 162. So now you know what that next term is. Now for V, we can do this. We can do a similar analysis, where we know that V1 is equal to 2, which is the same. Then we know when we see that it becomes negative 6, so you're multiplying by 3, but you're also making it negative. So you're multiplying by negative 3. And then if you multiply by negative 3 again, it'll become positive again, it'll become an 18. So you know that the R for V is equal to negative 3, and so on. So then you know that negative 54 times negative 3, you're going to get a positive number. When you multiply those two numbers, you're going to get 162 again. So you add up these two terms in order to get the next term of Wn. You get 162 times 160 plus 162, which is going to give you 324. Okay, now this is what the Wn sequence looks like, and if you keep, that's what it looks like. But now it says find the first three non-zero terms of Wn. So that's going to give, so the first three non-zero terms are 4, then 36, and then 324, because we skipped these zeros. And then you know it's 4, 36, 324, which is the answer to 2A. And it took a little work because you have to find the next number to the sequence of U and next number to the sequence of V, and then add them up and then take out the ones that are relevant. Okay. So the next question. Oh, why does it never copy it correctly? It's really annoying. Okay. 2B. This is perhaps slightly more difficult. I think the next part of the question is actually find the value of M. Okay, so now what they're trying to do for this, that's 3A, right? Okay, cool. So this is the information that's been given to us. I'm going to rewrite it. The sum from k is equal to 1 up until 225 of Wk is equal to the sum from k is equal to 0 up until m of 4r to the k. Okay, so let's think about this. I'm going to revert to this, and what we're trying to find out is m. So we're trying to find out what m is. Actually, let me make that red, just to make it a little more, let's drive it home. So m and r are what you're trying to find. Now, before we jump ahead and try and figure out what the values are, we're meant to solve it in the order first r and then m. So let's think about what exactly they're asking over here. This sequence over here, this sum over here, it's summing up a sequence, right? Obviously, there's some sequence where the first number is 4r to the power of 0. and then 4r to the power of 1, and then 4r to the power of 2. And you keep going until 4r to the power of m, and you add those all up, and that's what this sum is. And know that that is a geometric sequence. The first term is 4, then 4r, then 4r squared, then 4r cubed, and so on. And basically, and then let's look at so you know that this is a geometric series of some sort, right? And it's going up to some value m. Now let's look at what the WK is, right? WK is a sum of numbers, 4, then 0, then 36, then 324, no, not 36, then 0, then 324, and so on. Now WK is this, but when you sum it up, all of these zeros become trivial. They cancel out because the zeros aren't worth anything within the sum itself. So what you end up happening is you're actually summing up a geometric sequence, but the zeros are offsetting you a little bit because you look at your first term of 4, then you look at your second term of 0, then the third term of 36. Now, within the first 3 terms, you've hit 2 terms of a geometric sequence, but you've hit 1 term which is offset you a little bit, which is why the m value is going to be slightly offset a little bit. But essentially what's happening here is that you have the same geometric series over here. So if you're thinking about what the value of r is, which is a constant ratio, this is a constant ratio, you would look at whatever constant ratio you can see disregarding the zeros. So from 4 to 36, there is a constant ratio of times 9. And similarly, from 36 to 324, there's a multiple of times 9. So you know your constant ratio is r is equal to 9. So that's what your constant ratio is. And let's rewrite this little equation over here. So we have 225, and the sum, k is equal to 1, wk, and equal for m, sum from k is equal to 0, of 4 times 9 to the k, right? So 4 times 9 to the k. Now it becomes a question of the fact that these two sequences are kind of the same. If you look at the sequence 4 times 9 to the k, that sequence is 4, 36, and so on. But if you look at the 436 and 324, yeah, I just forgot what that was. 324, and so on. And if you look at the sequence WK, it's equal to 4, 0, 36, 0, 324, 0, and so on. Now, the way that we can actually figure out what m is and really, if we're able to do this, is to be able to understand sigma notation. And sigma notation is adding up numbers to some value and then noting and trying to figure out how many you have to add up together. So let's think about this in a very small number, because 225 is a massive number. It's kind of hard to see what's happening when you do the 225. But let's think about what we're saying just for a smaller number. Let's say 3, right? Say that this 225 number on the top over here was actually a 3, right? Let's say it actually was a 3. If it was a 3, that means you're going to add this term, and this term. So if you're adding these 3 terms together, you're going to get 4 plus 0 plus 36, which is the same as 4 plus 36, right? So that's all fun and games. But so when you add up the first 3 terms of WK, you end up only adding the first 2 terms of this new sequence on the right. So you only add up 2 terms in this sequence, but you add up 3 terms in this sequence. Now, what if we were doing up to 5 terms? So what if we were adding up 4, 0, 36, 0, and 324, all of these? Then the first 5 terms, you're only adding up the first 3 terms. So if you're adding up 3 terms, so if we look at this, so if you look at the WK sequence and the 4, 9 to the K sequence here, 3 of these corresponds to 2 of those, 5 of those corresponds to 3 of those, and then 7 of these is going to correspond to 4, and 9 of these correspond to 5, and so on. There's another pattern coming in over here. So now, if you know that 3 goes to 2, 5 goes to 3, 7 goes to 4, 9 goes to 5, with the general pattern which you can notice over here is that you're adding 1 and dividing by 2. So you're adding one number and then dividing by 2 in order to figure out what it is. That's the pattern that you notice. So if you have for 225, if using this little pattern that we've derived over here, then you can know that for 225, you add 1, you get 226. Then you divide it by 2. And the 226 divided by 2 is equal to 113. And that's what you know is for the 492k one for summing up the number of numbers. So then m is going to be equal to 113. And that's your answer. Okay. I think I noticed something a little sketchy here. I'm just gonna take a second to look at that. Oh, I noticed a little a weird thing over here. When you're putting it into the something over here, you're not gonna get 113. You actually have to put in 112 because you're counting from 0. You're starting from 0. Over here, you're starting from 1, which is fine. But over here, you're starting from 0. So if you wanted to look at the first 2 terms, you're only meant to count the 0th term and the first term. And therefore, if you want to get the first 113 terms, you need to count the 0th term, the first, second, third, all the way to 112, which is going to give you 113 terms, which is the correct answer. So this is your final answer over here. You know that R is equal to 9 and M is equal to 112. I think that's a chat message. See?
Wait, I don't get why it's 112.
Do you understand why it's 113?
Kind of.
Okay, so I'm only looking at how many numbers do I want to add up, right? And over here, this little something over here tells me I want to add up 225 numbers, right? I want to add up 1, 2, 3, 4, 5. I need to add the first term, second term, third term, fourth term, fifth term, all the way to the 225th term. I want to add up 225 numbers. But there's another pattern hidden inside when you compare this sequence with this sequence, the 2 different sequences. So if I'm looking at WK and I want to add up 225 terms of WK, that corresponds to only adding up 113 terms of the other sequence. So, and we know this because if you were adding up the first 3 terms of WK, you would get the first 2 terms of this sequence. If you're adding the first 5 terms of WK, you're only adding up the first 3 terms of this one. So every time you go up by 2 on WK, you only go up by 1 on the other sequence, on the blue sequence. So when you go up by 2 on the red sequence, you only go up by 1 on the blue sequence. So once you reach 225 for WK, adding up 225 terms, you know you're only going to reach up to 113 on the other sequence. So you know you need to add up 113 terms. But the reason why it's 112 is actually because over here, you know that it starts at 1, k is equal to 1. So you're starting at the W1, then W2, then W3. But over here, you're starting from, it's actually offset by 1, where you're starting off at the 0th term, then the first term, then the second term. So if you start counting at 0, you're gonna have to go back 1. So like if I want to count 10 numbers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10 numbers. But I've only gone up to 9. So if I'm ever starting my count at 0, then I need to make sure that I make it go backwards by 1. So if I want to count all the way to 113 terms, I need to make sure that because I'm starting at 0, I need to reduce that by 1 and make it 112.
Okay, so if I'm starting from 1, then it would be 1.
Yes, it would be 113 if it was starting at 1. Cool? Yeah. It's not necessarily exactly half of it, but you need to add 1 and divide by 2. So if you use 3 goes to 2, 5 goes to 3, 7 goes to 4, it takes a little bit to like notice that that's happening. But yeah, that's the main pattern. Okay, that's that. That's that question. That is a slightly. I think there's another part to it. No, there's another part. There's another part to it. This has a surprising amount of sequence and series in it. If you're ever in an actual test, like for IB, I don't think they're gonna give you this much sequence and series work, but it's okay. This is the next question. Cyanide, just avoid seal. Just don't. That's just more confusion. so annoying. It always happens. I'm just gonna. Okay, here, in an arithmetic sequence, u1 is equal to 1.3. Again, I'm writing it out because I always tend to do that. u2 is equal to 1.4. uk is equal to 31.2. Find the value of k. This is an arithmetic sequence. So what are the properties we know for an arithmetic sequence? We know u1 has to exist, and we know that it needs to be constant difference d, right? So u1 has been given to us. We know it's 1.3. And how do we find the constant difference? The constant difference is just, we need to find the difference between any two given terms. So we know that we have a term u1, we have a term u2. These are right after each other, so the constant difference between them must be d. So 1.3 and the 1.4, that's a constant difference of 0.1. There's a difference of 0.1 between them. So now that we have this thing and the fact that it's arithmetic, we know everything about the sequence. And now what they want us to find, and they're telling us that the kth term is 31.2. So we need to figure out what k is. And the way that we can do that is just by looking at our definition for what the nth term is. The nth term is un is equal to u1 plus n minus 1 times d. So let's look at that. So u1 plus n minus 1. So it's going to be, so un is equal to u1 plus n minus 1 times d, right? That's our nth term, right? So let's look at what our kth term is going to be equal to. So our uk is going to be equal to u1, but now let's replace u1 with 1.3 because we know that, plus k minus 1 times our d, which is we know, so we're going to plug it in, so we're going to make it 0.1. And we know that's equal to 31.2. So now look at this part of the equation over here and solve for k. I'm just going to do that. I'm going to do 0.1 k. Oh, that's horrible writing. 0.1 k minus 0.1 is equal to 31.2 minus 1.3. Let me just use my calculator for that because I'm bad at everything I do. 29.9. So 29.9. 0.1 k is equal to, add 0.1 on both sides, I get 30. K is equal to 30 divided by 0.1. I'm going to get 300. And that's my answer for this question. K is equal to 300. And you can check that again if you want to. So if you look at what U300 is, U300 is going to be equal to U1. Sorry, some weird things it's doing. Okay, so U300 is going to be U1, so that's 1.3 plus n, so n minus 1, so that's 299 times d, which is 0.1. And then if you see 1.3 plus 29.9 is going to be equal to 31.2. There, cool. So you know it works. And the next part of the question, find the exact value of SK. Again, exact value of SK, you don't need to try and derive what the sum sequence is. Go back to your formula booklet. Look at the sum of arithmetic sequence right over here. Have it right. Actually, I think it would be beneficial for us to use the second equation here. And I'll explain why in just 1 minute. Just 1 second. Our second equation over here utilizes the first term and the nth term, and we actually know the value of the kth term. So we actually know the value of our final term, which are adding up. So this is an efficient formula to use. So let's look at what we're doing. So SK is going to be equal to K over 2 times U1 plus UK, right? So we know what all those are. So we know K is equal to 300. So that's 300 over 2 times U1, which is equal to 1.3, plus UK, which is equal to 31.2. And you solve for this, you're going to get 150 plus 150 times 31.2, 32.2, 32.5, which is going to be equal to 4,875. And that's your SK value. Again, wasn't difficult. You can just use this, the formula booklet for this. If you want to, you could also have used the other equation. And it's the same thing. I just used the second one because it is slightly more convenient. But no, you can also use the other equation. It's completely fine. If you use the other equation, follow the same steps. Sk is equal to k over 2, 2 u1 u1 plus k minus 1 times d, and I end up getting is equal to 300 over 2 times 2 times 1.3 plus 299 times 0.1. And then I do all the math for here, and I'll end up getting 4,875, same result. Both of the equations completely fine. Just make sure you use one of them. That's 2 months. Here's the next question. So finally, we're not looking at sequence of series anymore. Yeah, I thought that would happen. For anyone new, I actually have the file in chat, and I think that if you're just joined, you won't be able to see the file. So I'm just gonna go to the chat and add the file again to show you the file that I'm using. This is the file that I'm looking at. And yeah, so that's the one. You guys can try and solve the question before I come, but I have to go. I have to go drink some water. I'll be back in a second. Okay, I'm back. Okay, this is the question. So The diagram shows a straight line L, points A, -9 minus 1, -9 x coordinate right here. So, and let me just label that quick. So that's -9, -1. M, -3, 2, so that's -3, 2 over here. And C are points on L1. Find the gradient of L1. So that's the first part. So the gradient, I'm not sure if you guys have a formula for this, but if you did, that would be pretty nice. No, you don't have a formula for that. You don't need one anyways. It's okay. I mean, you don't need one, but it would be nice if it was there just for fun. But whatever, it's okay. So the gradient formula is the gradient is finding the rise over run. So the change in y, so change in y over the change in x. So we know we have two coordinates. We have -9, -1, and then we have -3, 2. So we can find the change between these two coordinates. So getting from this coordinate to this coordinate, what are the changes? And we can use that for delta y and delta x. We could do the other way around. It's the same thing. It doesn't matter. And I can show you that. I can show that as well. So delta y is change in y. So -9 to -3. That's a change of +6. That's a 6. From delta x, that's change from -1 to 2. So that's a change of 3. So -1 all the way up to 2. So that means that my slope is equal to 2. Alternatively, if I wanted to, I could use it the other way around. So I could make the change go the other direction. I can make it go like that. And then if I want to, oh, actually, I made a little error there. I actually swapped the y and x values. The 3 is meant to be here, and the 6 is meant to be at the bottom. Sorry. And the 2 is 1/2. Yeah, I made an error. These are the x values, and these are the y values. So the change in y, it's the other way around. I made a small error, but a big error. It's a big problem. Don't do that ever. The change in x values the other direction is -3 to -9, so that's -6. And then from y to the change in y coordinates is from 2 to -1, so that's a -3. And again, that's giving you that's -1 over -2, which is again equal to 1/2. Same answer. Next part of the question. Is there a 4C? Yes, there's a 4C and also 4D and 4E and 4F. Amazing. That was a long question. Fun times. Find the coordinates of point C. M is the midpoint of AC. So between A and C, M is the midpoint to find the coordinates of point C. So let's think about how this works. And recall our definition of the midpoint. In order to find the midpoint of two different points, you add the x coordinates together and you divide them by 2. And in order to find the y coordinate of the midpoint, you add the two y coordinates together and divide by 2. So let's think about what we're doing here. We have M. M is the midpoint of AC. Okay, 1 second. So we have A, we have M, and we have C. And we have let's say we know what the x coordinates of A are. So the x coordinates of A is equal to -9. The x coordinate of M is also given to us. It's -3. The x coordinate of M is equal to -3. And the x coordinate of C is what we don't know. Okay. Then again, we know our y coordinate of A is equal to -1. And we know that our y coordinate of M is equal to, here is 2. And what we don't know is our y coordinate of C over here. But what we do know, because we know that M is a midpoint of A and C, we know that the sum of the y coordinates of A and C divided by 2 is equal to M. So YA plus YC divided by 2 is equal to YM. And similarly, XA plus XC divided by 2 is equal to XM. And you can solve and you can plug in the values you have here and solve for YC and XC. So let's do the Y first. we get ya is equal to -1, so -1 plus yc over 2 is equal to ym2. And then we know that yc is equal to 2 times 2, which is 4. And then 4 plus 1, it's 5. You can check that. So that's -1 plus 5 is equal to 4, and 4 divided by 2 is equal to 2, so that's correct. Then you can, now for the x one, you can do xa is equal to -9 plus xc over 2, which is equal to -3, which then I can do xc is equal to -6 plus 9, which is 3. So xc is equal to 3, and those are your coordinates for C. So, you know, and then just write it out again. Write down that C is 3, 5. Does that make sense to everyone? What I did there? I wrote out all the information I had, and then I wrote out the equations that what the midpoint formula gave it as equations, and then I realized that I can solve for it, and then solve for the thing, and I got that C is 3, 5. Okay. Next portion. It's a long question. It's gonna be a messy whiteboard. Oh, this is horribly annoying. Okay, let's try. I'll move here now. I'll move to this side. Okay, here. This is where I'll be. So for C, line L2 is perpendicular to line L1 and passes through point M. So just right off the bat, I'm going to say that L1 has some M, right? So M is M is our slope. So M1 is equal to, we came up with the slope earlier. So we know that the line 1 has a slope of half. So this might come in useful in the future. So I just want to write it out straight away. Half. And then L2, we know M2 is perpendicular. So we know L2 is perpendicular. And what we know about perpendicular lines is that the slope is equal to the negative reciprocal. So we flip the equation, we make it 1 over 1 over 2, and then we take a negative number. So what we're going to end up with for M2 is -2 as the negative reciprocal. So straight up, just from the first sentence on the top, I've come up with this information. L2 has slope -2, L1 has slope of half. So it's asking us to find the equation for L2, giving your answer in the form ax plus by plus d. Okay, so just forgetting about the form first, just finding the equation. Now we've already done a major step. M2 is equal to -2 from just the first line. So the general form is y is equal to mx plus b or mx plus c regarding how you've done it. But y is to mx plus b. We know what m is. Y is equal to -2x plus b. And then what we also know as another piece of information is passes through point M. So what it does is that this M value, which is, if I remember correctly from here, -3, 2. So what we know is that this value satisfies this equation. So what we can do is we can take the y value from here, 2 is equal to -2, and then the x value, put it in here, -3 plus b. Then solving for b, b is equal to 6, and then that's -4. B is equal to -4. The equation of L2 is going to be y is equal to -2x minus 4. And just quickly check that and if that's true, let's look back at what our graph looks like. Our graph is like this, a positive line upwards. So obviously we know that it's a positive line upwards. So in order for it to be perpendicular, it's going to be looking like this. It's going to look like that. It's going to be negative, and it's going to be a little steep negative. So it's -2x makes sense. So y is equal to -2x minus 4. But remember, they wanted it in a special form. They wanted all the x's on one side, all the y's on one side, and all the constants on one side equal to 0. So let's just do that real quick. We move everything to the left. So y is equal to -2x minus 4. We can make that into 2x plus y plus 4 is equal to 0. And that's our form. So yeah. That's our answer for 4C. Next point. It's a long question. And again, I fucked it here. Let's try. Here's a, okay, so the point NK4 is on L2. Now, what it means for a point to be on a line is to say that the x coordinate and the y coordinate of that point satisfy the equation that we've been given. The equation that we've been given. So straight up, we know this is our equation: 2x plus y plus 4 is equal to 0. So let's write that down real quick again. 2x plus y plus 4 is equal to 0. And we know that k is the x coordinate, so let's plug in the k into the x value right over here. And we know 4 is the y coordinate, so we put the 4 into over here. So we get 2k plus 4 is equal to 0. Solve for k. 2k is equal to -8. K is equal to -4. And that's our answer for k. That's how you find the value of k. Quick substitution. It's 2 more sections left. Find the distance between points M and N. I'm not going to copy paste that because I don't need to. Now we know that N is -4, 4. M is -3. That's a that's a bad 3. It's a demented ass 3. -3, 2. M and N are those two values. You want to find the distance. Go back to our formula booklet. If you look at the start over here, you have a distance formula. Note that over here, there's also earlier we used the midpoint. There's the midpoint formula over here. But here's our D. So D is equal to square root of x1 minus x2 squared plus y1 minus y2 squared. And what this means is that we can arbitrarily select one of them to be the first coordinate, the second coordinate. So I'm going to name n the first coordinate, m the second coordinate. It doesn't matter which one we do, the equation will work. So n is the first coordinate, m is the second coordinate. So x1 of the first, so the x coordinate of the first one, so that's -4. It's -4. Sorry, don't put brackets there yet. So distance is equal to square root of -4 minus x2 is the x coordinate of the second one, so that's -3. So -3 is +3. So I'm gonna square that, and then the y coordinate of the first one, that's 4 minus the y coordinate of the second one, that's 2. So 4 minus 2 squared. And then I get square root of -4 plus 3 is equal to -1. -1 squared is just simply 1. 4 minus 2 is 2. 2 squared is 4. So that's +4. And you end up with square root of 5 as your distance. Final question. This is where it's I think it get a little tricky. Oh, I could copy it over again. Perfect. Amazing. Just as I always wished for.
Maybe you're the problem.
No, you're the problem. You specifically are the problem. Oh God, this is a lot of work for one problem now. This is ridiculous. Okay, given the length of AM is square root of 45, find the area of triangle ANC. Let's go back and look at what the hell we've been doing so far. Length of AM is square root of 45. AM is square root of 45, and the area of triangle ANC. Okay, so let's go back to our I'm going to zoom in and see what exactly that means. So given that the length of AM is square root of 45, and the length of ANC, I forgot what N is. and is on L2. That's at negative 4, 4. And L2 is a line that passes through M. Okay. So I'm going to draw L2 first. L2 is a line that is perpendicular to L1, so it's going to look like that. Okay, I'm bad at drawing anything, so this is just, I'm horrible at everything, but this is what L2 looks like. I'm going to make it a little skinnier, so it's easier to write. And at N is a point that lies on it. It's negative 4, 4, so it's like negative and then 4, so it's like maybe here, you could say there's N. So they want you to find what A, N, C is. So it's this triangle here. And there's a right angle. There's right angles over here because it's perpendicular. So what you need to figure out is the distance between, you want to find out AC. Actually, what you can, another really cool thing is this is symmetrical because AM and MC are the same distance because M is the midpoint between A and C. So AM is the same as AC. So this is actually the symmetrical. These two triangles are the same thing. So you know that this triangle's area, say let's call it A, is the same as this triangle's area. It's also A. So we're going to try and figure out what A is. And if you saw right below what they said, they told us in that question over there, they told us that AM is square root of 45. AM is the square root of 45. So how do you find this triangle? So A is going to be equal to, first we find out what this one triangle is. The base is square root of 45, as said. Then we need to figure out what NM is, because that's the height. And we actually figured out earlier, the distance between those 2 points, which we found out D is square root of 5. So we multiply square root of 5, and then multiply that by half base times height. And then that's going to give us square root of 5 times, what does this give us anything interesting? What's 5 times 45? I don't know. 5 times 45, it's 225. 225. That's the square root of 225. Luckily, the square root of 225 is 15. So it's just 15 times half. 15 times half. That's what this is. So area is 15 times half. We need to double it because it's A plus A, so it's 2 times A. So we know that 2A is equal to 15. And that's our final answer for the area of A and C. There, we conclude this question, which was a long question. I hope that every part of that was somewhat understandable. Oh, we're not even close to done. What the hell is this monster question? I'm gonna like write both of these at once. So I'll come back here. Oh, hell away. Okay, the graph of the quadratic function. The graph of the quadratic function f of x is equal to half times x minus 2 times x plus 8 intersects the y-axis at 0, c. Find the value of c. There's 2 ways to go about this. And the first way is a little easier, which is to say that you know that 0c is a point that satisfies this equation. So let's think about what f of x equal to half x minus 2 x plus 8. How would you graph that? Because you would know that y is equal to half times x minus 2 times x plus 8. That's what it means. It means that the y coordinate is equal to half times x minus 2 times x plus 8. So if you had some value 0c, in order to figure out what c is going to be, you plug in this coordinate and then you just try and solve for c. So if we plug in 0c, we know the x coordinate is 0, and we know the y coordinate is c. So the y coordinate is c. So c is equal to half times 0 minus 2 times 0 plus 8. And look, it's literally giving us c is equal to this. So c is equal to half times negative 2 times plus 8. So negative 2 times plus 8 is negative 16. Negative 16 times half is negative 8. So C is equal to negative 8. Perfect. Another way to look at this is to first expand f of x. So if you expand f of x into half times x squared plus 6x minus 16 times half, so you made it into, sorry, half x squared. No, oh yeah, half x squared plus 3x minus 8. You know that whenever f of x is in this form for a quadratic, you know that there must be a that the constant at the end is going to be the y-intercept. So negative 8 is going to be your y-intercept. That's another way you could have figured it out. So these two methods you could have used in order to figure out the first question. Second question, the vertex of the function is negative 3, negative 12.5. Write down the equation for the axis of symmetry of the graph. So think about that for 1 minute. How is this 2 marks? This is interesting. Okay, so the axis of symmetry is the center of the quadratic. So essentially, if you're looking at the vertex, so if you were just quickly jot down, like draw a quick graph of this, you would end up with, if you had some quadratic somewhere, and this had some x and y coordinate, where this is the x coordinate and this is the y coordinate. This is your axis of symmetry, this big line over here, which passes to the x coordinate. So it's x, so basically it's x is equal to x. So it's like x is equal to whatever this value is. So the vertex here is negative 3, negative 12.5. So this x coordinate is negative 3, so it's going to be x is equal to negative 3 as the axis of symmetry. X equal to negative 3 is going to be the, you flip it backwards and forwards. Yeah. The next part of the question. I hope that makes sense, what I just did there really quickly. Okay, so f of x equal to 12 has 2 solutions. This is the symmetry of the graph. So second solution is x is equal to 4. Okay, yeah. So basically what it means by f of x equal to 12 is that if you were to graph f of x arbitrarily, whenever that f of x is equal to 12, that's when you're going to get solutions. So when f of x is equal to 12 is negative 10. So if we, let's again draw a little quick graph. So a quick graph, like so. And we're going to draw the axis of symmetry here as x is equal to 4. That's at 4. No, not x equal to 4. Where's the axis of symmetry again? And negative 3, sorry. It's negative 3. Oh, another mistake. This is the y-axis. That should have been 0. And that's negative 3. Should have been on the other side, but I didn't do that, so it's fine. We can just do this. And then this is our line for x is equal to 12. So when does f of x, this is f of x. So when does f of x equal to 12? So it happens over here and it happens over here. So we know that it happens, one of the solutions that they gave us is it happens at negative 10. So it happens here at negative 10. And then another solution they gave us, so they want to try and figure out what show the other solution is, which is 4. You know that this is negative 10 is correct. And then you need to like flip it over negative 3 in order to find what 4 is. So you basically like use the symmetry to flip it over. So you know that negative 10 is 7 away from negative 3. So this distance is 7. So you know that this distance also has to be 7. So negative 3 minus 7 is 10, negative 10. And then minus 3 plus 7 is going to be 4. So you know that x is equal to 4. That's how you use the graph to show the symmetry in correction. Write down the x-intercepts of the graph. Okay. X-intercepts of the graph. So let me just write down what f of x is again. F of x is half x minus 2 x plus 8. F of x is half x minus 2 x plus 8. Write down the x-intercepts is what was necessary. Sorry. Write down the x-intercepts. So the x-intercepts is basically when does the y value equal to 0? Because you're reaching the x-axis, right? Which is the x-axis is when y is equal to 0. So that means that any one of these factors, like you have these three factors here, we multiply by each other to get y. So either half is 0, x minus 2 is 0, or x plus 8 is 0. So the half obviously can't be 0 because it's always half. But the x minus 2 or the x plus 8 could be 0. So you need to solve for those. So x minus 2 can be equal to 0 or x plus 8 can be equal to 0. So then you know that when x is equal to 2, right, this is equal to 0. Or when x is equal to negative 8, this was equal to 0. So x is equal to 2 and negative 8. Those are the two x-intercepts. To be more specific, you can write down x equal to 2, negative 8, but you can also write down the actual coordinates. So you can write down the x-intercepts are 2, 0, and negative 8, 0, like that, to be more clear and specific. So that's better as well. On graph paper, draw the, oh my God. I can do this, but I don't know if I want to do this right now. Like, can everyone in the chat just give me in the chat or just turn on your mic and tell me, do you know how to solve this one question? Do you know how to do this? Okay, and I'll do it. I'll do it. So on graph paper, draw the graph. So basically what they're doing is they want us to draw it. That's all. So let's do this. I'm not sure how to use this ruler. Actually have no idea how to use this ruler. So let's, how do you use this ruler? How do you make it go round and round? How do you rotate it? Like, okay, let me think about this. I can.
The thing, you know.
What thing?
Circle. Yeah. Totally. I did that for you.
I think I know what I'm doing. No, I have no idea what I'm doing. Like this is ridiculous. Okay, here. Okay. I was like, I'm gonna go back. Oh, why does it go around with me? Oh God. Um. I'm gonna draw like 20 in each direction or something. Like that's what I'm gonna do. So I'm gonna draw. So. Okay. Okay. And then how do I like draw above it now? That's stupidity. You know, I'll just guess what the things are. It's fine. I'm not bothered enough correctly. 90, 90. This is not a good ruler application. Okay. Nice. Okay, now I'm gonna get rid of this ruler and I never want to see it again. 1, 2, 3, 4, 5. I'm gonna make it all 1 unit. So like, I'm not gonna write all of them out because it's gonna take too long. I'm gonna do the same for the down. So that's like that. Why is it there? What the hell? Stupid shit. One. Obviously, this is easier on graph paper, way easier on graph paper than doing a whiteboard. And yeah, I'll just try and find now how to graph it. So fy equals to f of x. Oh, what the hell? Yeah, y is equal to f of x. First thing I'm gonna make sure I do. I need to find out what the vertex is. This is a quadratic function, right? I need to find out what the vertex is. And if you notice a little earlier, they told us what the vertex is. They told us it's -3, -12.5. So that's the base, that bottom part. It's -3, -12.5. So x coordinate is -3, so it's here. That's -3 is here. It's -1, -2, -3. And -12.5, so it's -1, -2, -3, -4, -6, -7, -8, -9, -10, -11, -12, and -12.5 is right here. And up here. So it's approximately here. That's our vertex. Actually, I put this small. And that's -12, -3, -12.5. That's our vertex. Now, what we also know is we know what our x-intercepts are. So we found our x-intercepts are 2 and -8. So, so 2. So over here. And at -8, so that's -1, -2, -3, -4, -5, -6, -7, -8. So over here and over here, there are x-intercepts. And we also found out what the y-intercept was a little while back. We found the y-intercept was -8. So the y-intercept was -8. So that's -1, -2, -3, -4, -5, -6, -8, -7, -8. So it's over here. That's a y-intercept. So we know these pieces of information. I think that's enough to draw it. To quickly sketch it, you just draw from here to this x-intercept value. So that's one of the x-intercepts. So you know it's going to be there. And there's another one, and this passes through the y-intercept, needs to be passing through, and then passes through this x-intercept. I'm not very good at drawing it on the whiteboard, but here, that's generally should be okay. I think it should be more curved at the bottom though, like this part should be a little more like curvy. That's a little more accurate. Not curvy in that way, but curvy as in like better, just not bad. That's all. And then the other piece of information they tell us to actually do is, another little quick thing that they wanted us to do is a scale of 1 centimeter to represent 1 unit on the x-axis. So what they wanted us to actually do is that each of these units on the x-axis had to be 1 centimeter, but each of the ones on 1 centimeter on the y-axis had to be 2 units. So what they actually wanted us to do was that they wanted us to squash the y-axis. They wanted us to make sure that, so like if you were on your graph paper and you had like boxes of each one had 1 centimeter in length, the x-axis would be, each box would be 1 unit. But on the y-axis, each box would represent 2 units. So it goes 0, 2, 4, 6, 8, and so on. But I didn't do that over here because I couldn't like measurements. I couldn't do measurements and things. But yeah, that's something you need to do with like paying attention to. The other thing is the restriction. So -10 to 4 is what they want to do for x. So -10 to 4, they want to limit it from -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So they want us to have a restriction at this point. And they also want us to have, and they want us like restricted also at 4 over here at this point. And then for the y values, they want from -14 to 14. So that -14 is right underneath this, and then up to 14, which is probably somewhere up here. I can't tell right now. And what they want, so what you should do is you should continue drawing the parabola up until you hit these points, and then just make a hole over, and then make a and then just block it off. Oh, sorry. It's very inaccurate because of like just like bad stuff. Drop a hole here, and drop a hole here. Another thing which you need to make sure to do is check. Does it actually reach? Like you need to check what it equals to at the domains, because you need to check whether it reaches the up domain first or the bottom domain. Because like if you think about this as like a box here, right? You need to know, does the parabola hit the box over here or hit the box on this side? Like which side does it hit onto? So you need to like check what the what the value at this upper bound is, and also what the value at this left bound is, and then check which one it hits. To really make this proper, I'm gonna go into Desmos and just do all of the show you exactly what it looks like. And that's half x minus 2x plus 8. So half x minus 2x plus 8. And can restrict x to be 10x 14. Actually, I think it's the question asked for a less than or equal to, so that's going to be or equal to, and also the other condition of being between negative 14 y and being 14. Does it not allow? Oh, it only allows one condition? I'm not sure how Desmos is doing this right now. Wait, what if I do like that and I put a comma and I add another one? No, that doesn't work either. Why can't I put two restrictions? Does anyone know how to use Desmos properly, and why is this not working? I'm pretty sure you can restrict y values and also x values. I mean, I did do two different curly braces. Like, what the hell is happening? Where is it? There. Y is, oh, here, there. I had to put y is equal to. Why can't I see it anywhere? Wait a second. I made a mistake, clearly. Oh, I'm such an idiot. It's not 10 to 14. It's negative 10 to 4. Now I can see it. There we go. Yeah, my restrictions are wrong. Here. This is what it looks like. And note, it actually seems to be the case that it hits the sides before it hits the top. It never actually reaches 14 because the 4 on the side actually hits it before it can do that. Just to see what that looks like, you see x equal to 4. This is x equal to 10. I'm just drawing. I'm drawing out all the domains that I had written out. So y is equal to 14, y is equal to negative 14. So they wanted us to fit it inside this box over here. Note that the y coordinate boxes are is so big. Like the bottom is so small, like so low, and the top is so high. So like only the right side and the left side are the ones blocking it up. So this box is what's containing it. Yeah. Hello, Matt. You have just joined. I haven't. Oh, this audio isn't connected. Okay, whatever, it's fine. It's okay. On graph paper, draw the graph of y is equal to f of x for negative 10. Okay, done. Let t be the tangent of x. We write down the equation of t. No, again, give me the same one. Oh my god. Okay, let t be the tangent at x equal to negative 3. Write down the equation of t. The tangent at x equal to negative 3. So again, let me write down f of x one more time. Oh, I don't like the skinny version. I only like that for graphs. Skinny equals bad. F of x is equal to half x squared plus 3x minus 8, which I solved over here earlier. And because I know it's tangent, I know it's a derivative, so it's easier to do derivatives with this stuff. So f of x is equal to this. Write in the equation of t. So I need to find out what this tangent slope actually is. So I need to find out what f prime of x is. So I find half x squared. I can differentiate that by removing the power down. So I make that just leaves me with x. And then plus 3x is just plus 3, and then negative 8 disappears. So at the derivative is x plus 3. And then at x equal to negative 3 is what I need to find. So at x equals to negative 3, at f prime at negative 3 is actually just equal to 0. So the tangent is just 0. So if you wanted to figure out what the line is, it's y is equal to mx plus b. All it is just the m is 0, so it's just y is equal to b. So now we have to figure out what that b is. So what does that mean? So we need to know what because the 0 multiplies with x and just goes 0, that's why it's y equal to b. But what is b? B is going to be the value of y at that point, at the point x equal to -3. So if you plug in -3 into f of x, so if you take f of -3, and now it's easier to use the other one, like we had half x minus 2, no, x, was it x plus 2 or x minus 2? I can't. X minus 2 and x plus 8, okay. X minus 2 and x plus 8, and that's equal to half times -3 minus 2, that's -5, and -3 plus 8, that's 5. So -5 times 5, that's -25, which is equal to -25 over 2. So the y value at -3 is -25 over 2, and and that means that the y has to be equal to -25 over 2 as the tangent line. Now, another way that you could have actually figured this out very quickly and easily, because I'm an idiot, is to notice that the vertex is -3, -12.5, which means the vertex is this bottom portion over here, like that. So I already knew it's going to be equal to 0. The derivative is equal to 0. All I had to show, all I needed to do is just write down y is equal to -12.5, which is the same as -25 over 2. So what ended up happening is I did exactly the same thing as what I was meant to do, but in a longer and harder way to do it. But you could also have done it by recognizing that it's the vertex. And then you know what the tangent of the vertex is. It's just equal to the y value of the vertex. So yeah, I think that's the last. No, there's more. Draw the tangent t in your graph. So I'm going to go back to my graph, which is over here. Forward graph. And I'm going to draw the tangent t. It's right here. That's my tangent t. So that's t. That's f of x. And yeah. Now we have to go back for the last part of the question. F of a is equal to 5.5. F prime of a is equal to -6. State whether the function f is increasing or decreasing at x is equal to a. What? Okay, so you don't actually have to do any math for this question, because all you need to do is state, because f of a is equal to 5.5, f prime of a, wait, what? Yeah, f prime of a is equal to -6. So it's 5.5, -6 means the derivative is equal to -6, which means that the slope of that point is -6, which means that it's going downwards, which means that f is decreasing. And the reason for your answer is that the derivative is equal to -6, hence the slope is equal to -6. And that's your 2 marks. That's an odd question. I think the f of a is equal to 5.5 is going to like throw you off. But at x equals to a, it's decreasing. And that's because the derivative at that point is -6. And that concludes this entire paper. I have another paper that I could do as well. Which is anyone interested in seeing that one as well? It's not. I think it's not as long. Hopefully, I don't think so. I'll have a look at it. No, I don't want to open it. I'll open it. And I'm only meant to be teaching 3, 4, and 5. This looks odd. I'm not going to do this right now. It's all right. We've had a long enough session today. Yeah, I'll do this tomorrow, probably. I'll do the other one tomorrow, but this was this one. Yep, that's it. That's the entire session. I'm going to stop recording now.